If X is a binomial distribution where n and p is known, then we can use the GC to calculate. In this example, X is a binomial distribution where n is 15, p is 0.4. Then to calculate the probability when X is 5, we go to second vars to bring the distribution out. Then we press second alpha, enter, 15 to represent n, comma, p 0.4, comma, and 5. Enter. This means that the probability when X is 5 is 0.1859. In this next example, if we want to calculate the probability when X is greater than or equals to 2, we take 1 minus second vars alpha b, so that it is binomial CDF. Then we key in 15, comma, p 0.4, comma, 1. Enter. So the probability is 0.9948. In this next example, we want to calculate the probability when X is between 10 to 12. So we need to take cumulative probability of X up to and equal to 12 minus probability when X is less than or equals to 9. From here, notice only when we do this, then we can calculate the probability when X is from 10 to 12. So using our GC, we calculate as follow. Enter. This is the probability required. In this last example, we need to find the cumulative probability of X up to and equals to 7. So all we need to do now is to use GC binom CDF with n15, p 0.4, and x as 7. Enter, and the probability is as shown. In this section, we are going to explore on the shape of a binomial distribution. We are going to key in the probability of a binomial distribution where n is 10 and p is 0.2. Let's look at the shape of the graph. We use Zoom Stats 9. This is the shape of a binomial distribution when p is 0.2. Now, let's see what happens when n is still 10, but probability p is now 0.5. Notice now that the shape of this binomial distribution is symmetrical if p is 0.5 now. The mode is the value of x that is most likely to occur. The mode can be found by calculating all the probabilities and finding the value of x with the highest probability. In this case, this is the value of x that will have a highest probability. Let's read the next example. Of the inhabitants of a certain African village, 80% are known to have an eye disorder. This represents P. If 12 people are waiting to see the doctor, what is the most likely number of them to have the eye disorder? So N is 12. most likely number represents finding the mode. So we describe X as the random variable, the number of people who have eye disorder out of 12 people. To find the most likely number, we list down the probabilities of X using the GC. So we go to Y1 and key in binom PDF, where N is 12, P is 0.8. And we also need to go to second window, which is our table set. The table start should begin from 0. And the increment each time for our value of X should be 1. We scroll down the table to look for the maximum Y1 value. Notice this occurs when X is at 10. The probability is at its highest. So therefore, the most likely number of people is 10. Let's read example 9. Samples each of 8 articles are taken at random from a large consignment in which 20% of articles are defective. So we take 8 as N and P as 0.2. Find the number of defective articles which is most likely to occur in a single sample. So this means we are looking for mode. Using the idea mentioned in an earlier example, we go to our GC and we look for the value of X that will give the highest probability. Note in this case, the highest probability occurs when X is at 1 and the probability is 0.18. Let's solve the next part of the question. If 100 samples of 8 articles are to be examined, calculate the number of samples in which you would expect to find 3 or more defective articles. We need to describe a new random variable. Let's call this Y. Y is the number of samples out of 100 in which you would expect to find 3 or more defective articles. We are able to calculate the probability of obtaining 3 or more defective articles in a sample of 8. Now, this is our new probability for Y. Therefore, the expected number of samples with 3 or more defective articles is NP, which is 20. This is end of e-learning part 1. We hope you find it useful.